So let's have a look at some more questions from the 2014 Calc 1 University paper. So we'll have a look at question 19. So if f of 0 is equal to 1 and f of 2 is equal to 5, what is the average rate of change of the function over the interval? So we're going to be using a formula for this. We are going to be using the average rate of change as a function of x is equal to f evaluated at b minus f evaluated at a divided by b minus a. So this is a pretty standard rate of change formula. Now we are told that a is the first point and b is the second point. So this means f of a is going to be equal to 1 and a is going to be equal to 0. So f of 0 is 1 and x is going to be 0. And then f of b, this is a slightly unusual way to write these, but it shows us what we're going to be plugging into the formula, so it's fine. F of b is going to be 5, and then b is going to be 2. So now we just need to plug everything in. This gives us the area, or not the area, the average rate of change is equal to f of b minus f of a. So this will be 5 minus 1 over b minus a. This will be 2 minus 0. This will be 4 over 2. This is 2. And so therefore the answer is C, which is 2. So this is a nice easy one, just relies on average rate of change. So now let's have a look at question 20. So this is essentially a definitions question. It's asking us about the definition of something. It says, which of the following statements is false? So the way we do this kind of question, we look through and try and work out which ones are true until we find one that is false, and then when we find one that's false, that's it. So a function is continuous at a cusp. So a cusp is sort of like a turning point. So a cusp is sort of like if you have a function going down and then it pivots back up. This is a cusp. A function is continuous at a cusp. In fact, the function, you can draw it without lifting your pen off the page. That's essentially one of the simple definitions of continuity. So a function is continuous at a cusp. So A is true. B, a function is differentiable at a cusp. So this is not true. A function is not differentiable at a cusp. Something is not differentiable at a sharp corner. So this is just known to be true about cusps. One way to think about this is if a function has a cusp, the function is continuous at the point. The derivative, however, is discontinuous at the point. And so function is differentiable? No. So B is the one that's false, and therefore that's the answer. Now question 21. We have, what is the area between the graph and the x-axis on the domain for this function? So before you read these sort of look complicated, but these are really easy if you know what to do. So this is x, this is y. What is the area between the graph and the x-axis? The function is f of x equals 2. That is just a horizontal line that passes through y equals 2. So that is this line. This is f of x equals 2. No matter what the x value is, y is 2. And we have to go from minus 2 to 2. All right, so minus 2 is here, plus 2 is here. Sometimes people will do this as a derivative. You don't need to. This is just a rectangle. It's a rectangle with base length 4 and height 2. So the area in this case is just 2 times 4, which is 8. So area between the graph and the x-axis on this domain is 8, and this is actually none of the above. This is a really simple question, and this will trip people up because they'll see it, they'll try and do the integral. For students whose introductory knowledge of integrals is not very good, this is an easy integral to mess up. And if they get an answer like that's a multiple of 8, so a half multiple or a quarter multiple, 4 or 2, very easily you've got a wrong answer, right? So this is very easy if you understand what's going on in the question, but you can mess up, right? Students do mess these questions up.